think that I can start. I don't know how many more people are going to show up. My name is Alexa. I am a graduate student at UMass Amherst in the Stockbridge School of Agriculture. Just a little bit about myself. I grew up in New England, and I spent a lot of time working on small vegetable farms in both Massachusetts, New Hampshire, and Maine. And then I got my bachelor's degree at UMass in plant, soil, and insect sciences. And after that, I started working for UMass Extension. I worked both in the nematology lab there, analyzing plant samples that have plant disease samples that have nematode damage, and also for crop, dairy, livestock, equine, which is a team that deals with both cropping systems and animal systems. And there we were looking specifically at pollution from farming systems that was getting into waterways, things like that. And I was also managing a small medicinal herb farm at that time. And then I went to grad school. And the focus of my research in graduate school is all focused around the principles of regenerative agriculture, which I'm sure a lot of you know because you're here, prioritizes soil conservation and rehabilitation during food production. So what I'm particularly interested in is how do we build soil while we're growing vegetables, not only just in this sort of rotational way, but also how can we maximize our soil benefits while we're actively growing food. And also I'm interested in minimal soil disturbance, so minimal tillage, no-till methods, and enhanced natural soil fertility. And that's something I'm particularly interested in the context of climate change because our topsoil is eroding at an accelerated rate. I mean, in some places in the world, it's 30 times faster than it's being formed. And we rely, a lot of mismanaged soil, especially in conventional systems, really relies heavily on, I'm sure you know, chemical inputs and fertilizer inputs, which is unsustainable not only because synthetic nitrogen really relies a lot on fossil fuels to be created, but also because there's a lot of non-renewable resources like phosphorus that are mined and that are going to run out within the next 100 years. I mean, it depends on who you ask. Some people say within the next 30, some people say within the next 50. So if you're not managing nutrients in your soil appropriately, then you're going to be, SOL. And when that point comes, I mean, what are you going to do? So I'm really interested in natural soil fertility and keeping nutrients in soil, recycling them, not letting them leach and pollute waterways, and sort of keeping them on farm.
Is it?
Oh, yeah?
So, is this one supposed to be plain and garlic?
Yeah.
It
is. I'll get there. I'm just going to give a big I'm just going to start with the basics.
And for green mulch.
Yeah. And also, I mean, with the work that I do at UMass, I mean, I'm a researcher, so the way that we conduct our experiments are we have a research plot, we have a research farm, so we have all summer we're out in the field, and then all winter we're in the lab, which is why it's so exciting to do things like this and be here, because we get to hear from people who have experience. It's very humbling. Also have comments, so sometimes it's like, oh, that's a great idea, and sometimes that means it's like, oh, this would never work, and here's the million reasons why, and that's really good to hear, and that kind of input has really, really directed our research to be like, okay, well, no one's going to do this, or this is the part of this experiment that doesn't seem likely to work. So I really encourage people to participate and let me know, if you have opinions or comments or anything like that throughout the presentation. So this is our lab. I don't know if some of you may know Masood Hashemi. He's the big boss man. He's been around for a while. He does a lot with regenerative agriculture and soil health in Massachusetts. Very flattering photo of him, and then a less flattering photo of us after a long day next to a broken machine in the lab. So the research goals of our entire lab, I'm just going to go over this because I know that everyone in our lab, including Masood, really like for people to reach out with questions or with ideas and things like that. So our goal is to kind of produce applicable research so that if people have something that they're interested in, if it's something we can look into, we want to do that. So our goal is to enhance the sustainability of farming by integrating cover crops into diversified cropping systems to enhance nutrient recovery and recycling, weed suppression, and improve soil health. So we've worked with both vegetable systems and also animal systems and feed and forage. We're basically the main thing everybody in our lab does is takes cover crops and puts them into systems where they weren't before and tries to make that work. So we're interested, the main thing we're interested in is the integration of cover crops into vegetable production, grazing, and feed systems. The use of dual-purpose cover crops, which means that you can use a cover crop for both as a cash crop and a cover crop, or as like a forage crop and as a cover crop. So sort of maximizing your benefits out of a cover crop. We also work with introducing cover crops into the Northeast, so looking at which cover crops people around the United States or around the world are using, and then trying to see if they'd work in the Northeast. So we've worked with faba bean, which is really popular in California, sort of looking at time of planting density, things like that, and sun hemp, sort of see if those are viable options for the Northeast. We're also interested in perennial living mulch systems. That's something we're starting to look into. And of course, soil health, natural soil fertility, and tillage reduction. So, before I get into the planting into cover crops, I'm not sure, but I'm guessing you have some background with cover cropping since you're here, but I'm just going to go over some of the basics with cover crops. So cover crops are crops that are planted into fields at times where the soil would otherwise be bare, and they're usually planted for like soil health or regenerative purposes rather than for an economic harvest. So this is a great photo of a cash crop on one side and eroding soil on the other side. That's unfortunately really common to see all around the United States. Corn gets harvested in the fall, and then the soil just remains bare until the spring when it's planted again. So you have many months of just the soil being prone to erosion and nutrient leaching and pollution, because a lot of these fields also are fertilized heavily with manure, so you get a lot of phosphorus leaching and pollution of waterways. So depending on which cover crops you're you plant, you get different benefits, and that's how we select cover crops. All cover crops reduce erosion, and they do that in two ways. First, the living roots hold on to the soil so that it actually physically prevents it from eroding. And the general rule with soil cover is that if your soil is 30% covered with cover crop on the top of the soil, so you have 30% biomass, you can count on it to prevent erosion just through, if you can imagine water running off the top, just sort of catching that water with the density at the top of the soil. And that's why things like time of planting are so important in cover crop management, and research into cover crop management and appropriate land use management is so important, because you may think that just because you planted a cover crop, everything's good and great, but you actually need to pay attention to when you're doing it, and making sure it has enough time to grow so that you're getting those appropriate benefits. That being said, if you have the chance, you should always put one down. You shouldn't feel like discouraged about, if it's a week late, it's not a big deal. If it's a few months late, well, maybe you're just wasting money. So the other way, another thing that the living roots do is that the living roots are actually a big part of microbial diet. So microbes really rely on living root exudates for a source of food. So as the plants grow and cover crops grow, they send their photosynthase down to the root, and I think something like 30% of their photosynthase are exuded into the soil and used for food for the microbes, and they attract microbes to their rhizosphere. And that's why having a living plant in the soil is so important at all times, and that's why you should never leave your soil bare, because you're essentially leaving these microbes starving. So putting down a cover crop is sort of keeping those microbial populations in place at a time where you don't have a cash crop. And additionally, once those cover crops die, those residues also provide food for decomposer communities. So in any sort of stage of this cycle, you're feeding soil microbes. In addition, I'm sure, is everybody familiar with legume cover crops and the process of fixing nitrogen? So if you plant cover crops in the legume family, they actually are able, through a symbiotic relationship with a soil bacteria called rhizobia, they're able to fix atmospheric nitrogen. So based on your sort of cover crop and your production goals, sometimes planting a legume can be appropriate. Other times, if you're looking for something that's not going to decompose as fast, you wouldn't choose a legume. But having a crop that fixes its own nitrogen can reduce the need for nitrogen fertilizer over successor crops. So understanding these systems and sort of looking into how much nitrogen can you save if you're planting a legume cover crop is important, so that to make sure that you're not over fertilizing, or maybe you're saving costs by reducing your nitrogen fertilizer use. Another benefit, nutrient capture and recycling. This can be done by cover crops with tap roots, which is like this tillage radish goes all the way down. There are some nutrients that are really far down in the soil horizon, and cash crops can actually access them. These kinds of cover crops that have a really long taproot will actually get down to get those nutrients, bring them back up to the surface, and as they decompose, which tillage radish decomposes pretty quickly in the spring. If you plant it in the fall, in the spring it'll decompose. Those nutrients will then become available to a cash crop. Actually, very fibrous roots will sort of do the same thing. They'll scavenge the soil for nutrients, and then when they die, they'll re-release those. This is also really important for when you're fertilizing in the summer. If you're putting down fertilizer and then you've harvested your cash crop, but you still have some fertilizer in the soil, that's going to leach, especially with nitrogen, it's going to leach in the winter. But if you have a cover crop, it'll absorb that nitrogen, and then when that cover crop decomposes in the spring, that nitrogen can become available to a crop that you're planting in the spring. So for that reason, this nutrient recycling can be really important, so that you're not losing the nutrients you've put down, or the nutrients that are in your soil. You're sort of bringing them back up to the surface for your next crop to use. And this can be especially useful in no-till systems, where you're really trying to preserve a lot of the nutrition that's in your soil. And of course, compaction, alleviation. Tillage radish is called tillage radish because it kind of tills the soil in a way by creating these really deep tap roots, and also like some of these things get really, really huge. Weed suppression, so this is common in corn systems. Now people are planting rye. That's doing a good job at suppressing weeds. That's where selection of cover crops is really important, because you need to have you have to make sure that you're choosing something that's not going to decompose really quickly if you're looking for weed suppression, that's going to produce a lot of biomass, or something that's going to be easy to terminate, like rye. I mean, you have to mow it at a certain time in the spring. You have to sort of think about these management things, but weed suppression is another common goal of planting cover crops. And of course, all cover crops build soil organic matter and sequester carbon. So that's another added benefit of just between leaving your soil bare or planting a cover crop. I mean, you're always going to be building soil organic matter by feeding the microbes and returning this plant material into the soil. And also carbon sequestration. Having living plants in the soil is always going to draw down carbon. So while it seems like a really small thing on a small farm, if we're being forward-thinking and thinking about global agricultural systems, if this was a common practice and people were always having living plants in the soil, we would be sequestering a lot more carbon than we are now. So this is some of the considerations we use when we integrate cover crops into production systems, and these are some of the considerations I use for considering which cover crops to choose when planting garlic into cover crop systems. First is anticipated benefits. So that comes along with, in my case as a researcher, I look at a system and say, okay, what's not sustainable about this system? And then I think about what can I add to this system, and how can I make it more sustainable? What do I want to see in the system? And then that really informs how I choose my cover crops. 2, field history, very important. If you were planting a cereal grain, you might not want to, crop rotation, you might not want to use a cereal cover crop. Similarly, if you just fertilized a lot with nitrogen, you may not want to plant a legume, because the bacteria that actually fixes nitrogen with legumes is really sensitive to nitrogen fertilization. You might not really get the results you're looking for if you're not aware of some of these interactions, or you're not considering what your field history is. Then production cycle timing. That is more about when are you going to harvest, what are you planting, how long is your cover crop going to grow, is it going to take it, are you going to have to mow it at some point, is it going to produce the right amount of biomass? One thing, is it appropriate for your system? Like, for instance, I would have loved to use rye for this garlic cover cropping system, but it's just not going to work because you have to mow it in June, you harvest garlic in July. You have to sort of plan these things out pretty well if you're going to be integrating cover crops into production systems. Also, applicability goes along with that. Something might seem like a great idea in theory, but then you get down to doing it and you're like, this is like a huge pain. It's really time-consuming, labor-intensive, expensive because of that. And then the last thing, which is something I'm very interested in, I think is one of the most important things, is residue decomposition and nutrient release, which I think really varies system to system, but is especially now that we're looking more at no-till systems, reduced tillage systems, and different we're changing the microbial communities on our farms. Paying attention to residue decomposition and the release of nutrients and the capture of nutrients is especially important. So, are people familiar with carbon to nitrogen ratio? So this is one of the things that we use a lot when we're looking at cover crops and decomposition. So all plants and manure and microbes, they have a carbon to nitrogen ratio, and that can be used to predict nitrogen availability and decomposition time. So carbon is used as an energy source. It's necessary for photosynthesis, while nitrogen generates proteins, amino acids, enzymes, and you need both for both microbe metabolism function and for plant function. So when you have cover crops or anything growing that's going to decompose, you can have things with a high carbon to nitrogen ratio, which means that it has a lot of carbon to a little bit of nitrogen, or things with a low carbon to nitrogen ratio, which means lower amount of carbon per unit nitrogen. So for the microbes, their ideal carbon to nitrogen ratio is 24 to 1. So if you have something that's much higher than that, then your residue is going to take a lot longer to decompose. And the reason for that being is that the microbes will start to attack the residue, and they'll start using up the carbon, but they won't have enough nitrogen. So then what happens is, where do they get the nitrogen to digest that carbon? Is they start to look towards the soil. And at this point, they start to pull nitrate out of the soil, and they start competing with plants for the soil available nitrogen, and they're immobilizing that nitrogen, which means that they're using that nitrogen, and they're making that nitrogen not plant available. So when you use a residue, or you have a residue, or some people put wood chips in. I don't know if you've ever seen wood chips kind of incorporated into soil, not as a mulch, but further down. What happens is these microbes have all this carbon from this residue, but they're using the nitrogen for the soil. So they're actually robbing plants from the nitrogen that they could be using, so you could actually be creating more of a problem. However, these types of residues could be really good for mulch. So if that's your goal and you're looking for like a cover crop that's going to produce some cover, it's not going to be incorporated, this might be appropriate. So some examples are rye, oat, straw, things like that, things with a lot of lignin. Residues with a low carbon to nitrogen ratio, you have faster residue decomposition time. So if you're picturing like a nice leafy green, it's going to decompose much faster than something woody in the soil. There's enough nitrogen for it to be available to plants right away, and that the microbes aren't competing with plants for soil nitrogen, so you're not robbing plants of soil nitrogen. And that's why amendments like manure and compost are so common and are good in these systems, is because they release nitrogen that's immediately available to plants. So here's a little example. Here you have your ideal microbial diet. So you've got a lot of manures, hairy vetch, legume down at the bottom with low carbon to nitrogen ratio, rye, oat, corn stovers, that's all up at the top, high carbon to nitrogen ratios, which means they're going to take longer time to decompose, and you have to be aware of the nitrogen situation in your soil. So the questions that we're interested in, and I think that everybody should ask themselves when they're planning to, when they're designing these types of systems, are how quickly do plant residues decompose? How quickly do the nutrients in those plant residues become available to successor crops? And that has to do with microbial activity, because you might have a nutrient that is available, but it's not in a plant available form. What can influence the rate of decomposition? And how do plant residues compare to other organic amendments in terms of decomposition and nutrient release? So this is something that we're working on at UMass as well, is sort of looking at, if you are using cover crops and relying on them for nutrient release, how does that compare to just putting down manure? And that's important when you're thinking about synchrony. if you have a cash crop that's actively growing, at what point is it going to need that boost of nitrogen? Is the decomposing residue going to provide that for it, or is the manure? I mean, the manure might not either. It might provide a big boost of nitrogen at the beginning, but then you might not get that sort of slow release over time. So we're looking at that. It depends on the crop you're growing as well. If you have something with a longer production cycle to a shorter production cycle, your needs are going to be different. So just a little bit about decomposition, and I promise we're getting to the garlic and cover crop, but it's all related. So decomposition is a biotic process that relies on soil microbes to turn residue into soil organic matter and makes nutrients plant available. So microbes, we've already talked about, need the carbon and nitrogen. That's where the carbon-nitrogen ratios are so important. And what actually makes up soil organic matter is the dead microbes. After they've processed and digested the plant residues, they die and they stop metabolizing, and then their dead bodies are basically what soil organic matter. That's what builds your soil. So you start with plant residues. The first primary decomposers are bacteria and fungi. They're the first thing that will attack the plant residues. Bacteria are like the primary decomposer. In heavy tillage, you'll see a lot of bacterial activity. Fungi will help break down lignin in plant residues. And once that starts happening, then you've got invertebrates, nematodes, and other microbes coming in, eating the bacteria and fungi, and then decaying and dying and becoming soil organic matter, which will feed crops. So it's a big process. And one really important thing that kind of ties in with production systems is that a lot of these microbes don't like to be disturbed. So if you do have a lot of disturbance and heavy tillage, you're not going to see a lot of like earthworm activity because the microbes are smart. And if they know that there's a lot of heavy disturbance, they're just not going to establish themselves there. But also, as we look at systems that are undisturbed for a while, our microbial populations are really changing. So it's important to sort of look at and observe these changes and look at how our decomposition is being affected, because as we see, decomposition is really driven by these soil microorganisms. So, on to garlic production. Going back to sort of how we design these systems, we're looking at the garlic production system, and I'm seeing a lot of unsustainable, well, actually, let me put it in a less negative, more positive way. There's a lot of promise to increase the sustainability of this system. So it's a 9-month production cycle, which is a very long production system, which is something that really interested me about garlic production. So currently planted in October, mulch with straw, plastic. I just talked to somebody who used Reme. So mulch to prevent temperature extremes and frost heaving, and then it starts growth in early spring. So for most of this time period, your soil is, it's not bare in terms of erosion control, but you're definitely not sequestering carbon, you're not feeding your soil microbes, and you're basically not doing any favors for the environment. So what our research team asked was, how can we enhance the system to maximize ecosystem benefits? What we came up with was reduced tillage through the use of cover crops and arbuscular mycorrhizal fungi. So the idea is we plant cover crops in September after harvest, or whatever, it's flexible date. We originally started in August, and then we talked to some people who were like, well, I'm not done harvesting in August, but this would work if I were to plant cover crops in September. So if you plant cover crops in early September, you let them grow until they're winter killed in December, so you're planting things that are not going to overwinter. And then we planted with a grain drill, and then we let these cover crops grow into October. And in October, we came through and planted just between the rows garlic. And at that time, we inoculated it with arbuscular mycorrhizal fungi. And one of the biggest concerns was, are these cover crops going to be able to produce enough biomass in this amount of time to give us the benefits? Also, one of the things I was concerned about, and from hearing people who have tried this system with draft horses, it seems like this could have been a problem, was planting into the residues. So we planted by hand, and let me tell you, it was a treat. It was like a Fern Gully moment where it was just the cover crops, the soil in between the cover crops was really just teeming with life. There were so many insects, there were so many worms just crawling into the holes with the garlic. It really was it was so aerated and fluffy compared to like we have to do controls and research. And I wasn't, I mean, just from like a physical observational perspective, I wasn't really expecting to see that, and wasn't expecting it for it to be that easy and easy to get in there. I thought it would take a lot longer than it did, but that worked really well.
Sorry, did you say what your cover crop was?
I will. I'll talk about them in a second. I'm going to go over first a little bit about the mycorrhizal aspect, because that's something that I'm really interested in terms of, especially with no-till methods, and that's something that's part of this system. It doesn't have to be. Originally, we were just thinking, okay, cover crops, garlic into the cover crops. The idea is that then the cover crops die, and then before the garlic sprouts, they start to decompose. So as they're decomposing, those nutrients are being released to the sprouting garlic. So there's some synchrony between as the garlic's actually sprouting in the spring and the nutrient release from the cover crops. So then you can maybe not fertilize as much, or you get some extra nutrients from that. But then we decided to add mycorrhizae to the system. So mycorrhizae is a symbiotic relationship between fungi and plant roots. It occurs naturally in forests. So that's sort of, it's actually, I guess, not totally new to agriculture, but I think it's especially important in the context of climate change as we're looking at new systems, and we're we're actually starting to do more no-till and reduced tillage systems. It's important to utilize some of these tools. So there's two types of mycorrhizae: ectomycorrhizae, which are mostly found colonizing trees and other woody plants. So you're not really going to see them in agronomic systems. And they colonize the outside of the root. They actually get in between the root cells, but they're not really invasive. They don't go into the root cells themselves. And then there's endomycorrhizae, which penetrate plant roots, and they form these little arbuscules, and then they're able to exchange resources with the plant. So there's a photo here. So here you have, basically, this is a pine seedling, but this is the basic idea. Is you have this network of roots, and then you have arbuscules that form. This fungi enters the plant root, forms these little arbuscules, and then it spreads this network of hyphae out into the soil. So in exchange, the plant provides the mycorrhizae with carbon and photosynthates, and in exchange, the mycorrhizae will seek nutrients that the plant roots can't access and send them up to the plant. And then at that point, it's a cycle, because the more carbon that the plant sends down to the mycorrhizae, the more the mycorrhizae grows, the more nutrients they're able to bring to the plant. So there's that. Also, this is really great for carbon sequestration, because the more carbon that the plant brings down to the mycorrhizae grows. So you're actually able to sequester more carbon with a mycorrhizal association than without. In addition, why we chose it especially for garlic is that it can increase garlic nutrient use efficiency, and there have been studies that have shown that arbuscular mycorrhizal fungi really positively increases the nutrient use efficiency of garlic. Also, this is something that I was excited about. It can enhance the flavor and the nutritional quality. So the compound that makes garlic really pungent and spicy is allicin when it's in the garlic, and then when you cut it up, it becomes allicin, and that's sort of the flavor profile of garlic, or gives garlic its flavor profile. And so it's been shown that arbuscular mycorrhizal fungi can actually increase the allicin content in garlic. Just from like a cooking perspective, if you chop up garlic and let it wait for a few minutes for a lot of that allicin to oxidize, you'll have a more pungent flavor, just because that allicin is going to oxidize into allicin. And the reason that people think that this happens, and they've done this research with medicinal plants too, is that allicin is a secondary metabolite in plants, which means that it's not required for the plant to normally function, but it's kind of used as a defense mechanism. So when arbuscular mycorrhizal fungi enters the plant root, it activates this plant defense mechanism, which in garlic gives it some pungency. In some medicinal plants, it's also it can be that compound that makes a plant medicinal. It can actually increase that compound just because it's a secondary metabolite that makes that's activated when the plant activates its defenses. Then it increases soil health and microbial diversity. In the spring, it can also really help with residue decomposition. As we talked about before, fungi are really important for decomposition. They're one of the primary decomposers. So if you have a high population of fungi, then you can actually speed up your decomposition. So it's also been shown that cover crops really increase arbuscular mycorrhizal populations. They really associate really well with these, which is another reason we chose to do this. It's been shown that mixed cover crops and sort of a polyculture is especially good for arbuscular mycorrhizal fungi. And so the idea is that when you plant the garlic and you inoculate it with arbuscular mycorrhizal fungi, it uses the cover crops as a nurse crop in the fall. So basically it starts to associate with the cover crops. And then when the cover crops die, in the spring, the cover crops are dead, but that arbuscular mycorrhizal fungi population and network is there, and it can move on to the garlic and provide these benefits to the garlic. So in this system, the benefits of the cover crops are the living roots feed the microbes until December. Otherwise, you really don't have any food for the microbes in a garlic planting system for a few months at least until the frost comes. Roots and residues prevent erosion. Decomposing residues provide sprouting garlic with nutrients, and of course the carbon sequestration. So these are the cover crops that we've chosen for this project. Oat, this is a major one. We chose it for a few reasons. First of all, it's fast growing. It produces a lot of biomass. We really hope that it'll suppress weeds in the spring because of its slow decomposition. Also, it captures a lot of nutrients, so it can recycle them into the soil as it decomposes. And of course, erosion control with both the above ground biomass and the below ground roots. Forage radish, also very quick to establish, very fast growing, alleviates compaction, can recycle nutrients from deeper down to the soil, and this adds a lot of soil organic matter. It decomposes pretty fast in the spring, so we're excited to work with that. Winter peas, fixed nitrogen, really cold hardy, so they might actually be out in the field a little bit longer than the other cover crops, and quick to decompose. And then mixed cover cropping system, which we're actually expecting to see the most benefits from. So this is our first year doing this, and we haven't looked into the yield and the nutritional quality yet. So we're not entirely sure if we're going to see any differences, but this is the most promising for us because, one, we think we're also looking at things like soil microbial populations. We think this is going to give us the most soil health benefits. It also, I think, is going to be especially good because you have the benefits of the oats, which are providing some mulch and not going to decompose as quickly. You have the benefits of the legume, which is fixing nitrogen, and you have the compaction alleviation and the rapid decomposition of the forage radish. So you're sort of combining this into a cocktail of benefits. You're also increasing biodiversity, so you're increasing resiliency in that way, and also better associated with arbuscular mycorrhizal fungi. So the basic timeline is that in September, you plant your cover crops, and they start to establish and produce biomass. In October, you're planting between the rows of the growing cover crops. At this point, we inoculated with arbuscular mycorrhizal fungi, so we just used a commercially available product called something really funny, Mycorrhizae, like a leprechaun, Mycorrhizae, but it's all basically, they're all glomera. The type of fungi it's a glomera fungus. There's different species that associate with different crops, but a lot of these commercial companies, what they've done is they've combined several species so that you get better association. So that's the product that we used is basically a combination of a few different arbuscular mycorrhizal fungi. And we chose to do that because we didn't want to get too specific, because we want this to be a system that works with different cover crops and not just this specific one thing. The other thing is that soil naturally has arbuscular mycorrhizal fungi, and because we're working on a research farm and we're not working within an established no-till system, we decided to inoculate. We think that what would happen if we continue to work in a no-till system is those populations would establish, and then you wouldn't have to necessarily inoculate every year, which is one of my concerns because I think that it's expensive for people to buy something like Mycorrhizae and just put it in their soil and do it every single year. The drawbacks of that are you're obviously not going to plant garlic in the same place year after year, but I mean, if you are working within a diversified production system, you could put something else in that is going to associate with our arbuscular mycorrhizal fungi and keep those populations there. I mean, brassicas won't associate with arbuscular mycorrhizal fungi, but plenty of other crops do. So you can actually build this network over time, especially if you're working within a reduced tillage system. Tillage will disturb the hyphae, and it will disturb the mycorrhizal fungi. I don't know how much so. Like, I don't know how much the populations will, like the overwintering spores or the desiccated spores will stay in the soil and establish with the next crop. I don't think it's going to totally devastate everything. But of course, it doesn't like to be disturbed. I mean, like most microbes in the soil, it prefers these sort of undisturbed systems, which is why I think this type of system is especially appropriate because it's a 9-month production system where you have all of this time for these populations to establish. So here's a picture of what it kind of looks like. It actually looks a lot crazier from this aerial view than sort of clean in between the rows, but garlic 6 inches apart, and then 1 teaspoon of the commercial mycorrhizae. So that's with forage radish or tillage radish. As you can see, that's coming out of the soil. There's some more photos here.
So you just put some AMF around the garlic.
Yeah, because I was planting by hand, and I think this is where I'd love to hear input, is the way that we planted garlic was by hand.
Yeah.
And so if people are using some other system, this might be a little bit more challenging, and then maybe applying the mycorrhizal fungi would be more challenging. So this was very specific to that. Also, depending on the type of cover crops you use, like we've heard that getting through like oat can be difficult, if you're just because of the amount of residue. Also, it depends on like how wet or dry a year it is, right? So.
So when you say you planted between the rows, how far apart are the rows?
So the rows are 10 inches. So then we planted in between the two. So basically, it was very, oh God, there's no markers.
Oh, they're on the table.
Oh, okay. Yeah, so we had, I think, it was 7 rows, and then we just went through and planted like that. So
And this is very small scale.
this is very small scale because it's a research plot. So we planted probably something like a 1/4 acre. So very small scale on this side. But we would be interested in looking at how it goes up and down. But obviously, when we're doing research at the university, because all of these, every single plot that we have, we also have to sample from and analyze in the lab.
So the cover crop's going to die.
Yeah.
Frost hits. Then did you put mulch on top of?
So that's something that I think I'm going to mulch in the spring. And so this is our first year, so we haven't really seen what the spring is going to look like. Right now, in the fall, we didn't put any mulch on. And there was so much biomass that you didn't have to. So one of the big questions is going to be which systems are you going to have to mulch and add that sort of supplemental mulch? I don't think you're going to have to do it until probably like May or April, because the weeds aren't going to... For weed suppression, only for weed suppression. And so I think that the oat is going to perform the best for that. I think the mixed cover crop might perform well for that. But I think that just the pure legume, I think it's going to have very poor weed suppression. I think that's going to need supplemental mulch. So we'll see in the spring for what that looks like. But basically anything with like more lignin or higher carbon to nitrogen ratio is going to do a better job. And if it can get through the season, that'd be great. I think some of these systems on their own aren't going to perform really well with weed suppression. So that's more photos. This is actually one of the mixes. Yeah, this is a mixed system. So you have the forage radish and the oat and planting in between. And I think that's just another forage radish there. So that's what the biomass in a mixed system looks like. And this is actually planted with fava bean instead of, you can see the kind of fava bean peeking out, instead of, we're going to use field pea next year. We were experimenting a lot with using fava bean as a cover crop just in general. So that's why we used it this year. I don't like to use it because you have to hand seed it because it's so variable in size that you can't just put it into like a grain drill or something. That's why I'm not going to use it anymore. We're going to do field peas next year. But yeah, so a lot of biomass. And this was taken sometime in October, and it continued to grow up until winter kill. So then November, our arbuscular mycorrhizal fungi establishes and uses the cover crops as a nurse crop. So you have these few months for the arbuscular mycorrhizal fungi to sort of establish around the cover crops. Cover crops continue to produce biomass. And then in December, the cover crops winter kill. In the spring, garlic sprouts and begins active growth, and the cover crops residues decompose. In summer, harvest garlic. So the in-between thing here is maybe apply mulch, but we're just not sure yet, and we're not sure what that's going to look like, because that really depends on the cover crop residue decomposition.
What mulch options are you guys considering for that?
We're mostly just going to put down straw, because, I mean, at this point, I think it's going to be, I think we're only going to do straw, because I don't think we're going to have to put it on all the plots, and I think it's just going to be a very, we need some here, versus, we're not going to put the plots.
Do you think the residue is going to be such that if instead of a mulch you wanted to just, hoe it, or, if you're in a tractor, cultivating, 3-row, whatever you're doing, hit it a couple times instead for weed suppression? You won't be able to
I think
do
that's
that
a great
if the
question.
residue is too...
I think that's a really good question, and I think that with some of the residue, I think I think with the forage radish, definitely. I think with the field peas, yes. I think with the oat, I think it depends on when you try to do that. I think that the residues might be too dense to really go through it with a hoe or a cultivator. But really, I'm not sure because we haven't seen it in the spring yet. But yeah, I think that depending on what you plant, that's definitely a possibility. I mean, the ultimate goal of one of my ultimate goals, just to reduce labor, would to be try to find something or some sort of mixture that you don't have to mulch or you don't have to really.
Higher percentage, messing around with.
Exactly. In your mixture, So that would be ideal, just because it would save labor.
That's the dream.
But that takes, that's the dream, and that, obviously takes trial and error and all of that. So it's very preliminary. And the way that we're going to look at these systems is we're going to look at, of course, the garlic yield, number of cloves. We're going to look at the nutritional quality. That's something that's really important, I think, especially in, small-scale systems. And if you look at, the bigger picture, too, in terms of, a change in climate, just making sure, as more nutrients escape the soil, making sure that we're still producing nutrient-dense crops. So looking at if any of these systems, the addition of arbuscular mycorrhizal fungi or growing in a polyculture cover crop system can actually affect the nutrient density of these crops is important. But in addition, we're going to look at the soil health. So soil structure, aggregation, water retention, things like that. Are people familiar with the Cornell soil health? I don't know if that's... Basically, there's a set of ways that you can test your soil to see sort of how it compares, whether it's compacted and what kind of microbial activity you have. The easiest way to do that is earthworm activity, and that's a kind of a good indicator of how active your soil is. And the way that we do that, and that's something that you can do really easily, is you basically dig a hole that's 1 by 1 foot, and then you count the worms in it, dig out the soil 1 foot deep, and count the worms, and then you pour a mustard solution to it. You just take dried powdered mustard and you shake it up in water and you pour it in, and you see how many more worms come out. Now, there's these thresholds that you can actually see, sort of use them to determine how active your soil is. So we're going to look at how the soil is affected by all of these systems, because that's something that we're primarily interested in, is soil regeneration and soil health. And another thing that we're starting to do, which is something I'm really passionate about, and I think I really hope to see be more applicable in farming systems, is using nematodes as indicators of soil health. Are people familiar with nematodes and what nematodes are? So they're roundworms that are found in every soil. They're found everywhere, actually. But they use this a lot in environmental research, but they also use it globally in agricultural research. So nematodes are found in every soil, and they're a really good way to figure out what's happening in your soil because they have really, really quick life cycles. And depending on the type of nematode, there's basically 5 types of nematodes. Some eat fungi, some eat bacteria, some eat other nematodes, some are plant parasitic, some eat everything. So because they have such a quick life cycle, you can look at the nematode populations in your soil, which are really easy to do. Like, this sounds like a complicated thing, but it's really not. I mean, you do need a microscope, but they're aquatic, so you just basically flood your soil and they come out, and you can understand what your fungal populations look like in your soil, what your bacterial populations are like. If you have a lot of plant parasitic nematodes, that's pretty indicative of an unhealthy soil. Bacterial feeders are when you have a lot of bacterial nematodes. That means there's a lot of bacteria in your soil, which is indicative of usually happens after a lot of tillage. They're the first thing to attack and sort of start mobilizing. Fungi is more found in forest soils or soils that have been undisturbed, but this is especially important, I think, as we move towards different types of systems to understand what the microbes in the soil are doing, because that can really influence our long-term management strategies, because these microbes are what influences decomposition, influences nutrient cycling, things like that. So, So basically, kind of to summarize what I just said, you have reduced soil disturbance, you have an increase in microbial populations. That leads to changes in decomposition and nutrient cycling, so that's one of the reasons that it's really important to do this kind of observational work. And that's why, working as a researcher, these are the types of things I'm interested in, because I do want my research to be applicable, but I also want to track some of these more, these smaller changes that are microscopic, because they do have such a large effect on our yields and our nutrient density and things like decomposition. And so I'm almost done, actually, so very early, but just to reiterate the benefits of the intercropping garlic into cover crops: increase the soil health and natural soil fertility, minimize soil erosion. Big one is you're feeding the soil microbes both in the fall and in the spring, so you're really keeping them fed in a time that they'll basically be starving the whole time. Reducing off-farm inputs and sequestering carbon. And that's it. So does anybody have any comments or questions, or anybody have experience with doing this, or see anything that they...
You used a commercially available
A what?
You used
our Mycorrhizae Mycorrhizae fungi.
Is there like a natural source? I know you talked about wood-based fungi, but is that like too little to really make a difference? Is it hard to integrate that from
I think it depends on what your system looks like. I mean, so they occur naturally in the soil. And I think that the reason that we choose to inoculate is because, first of all, they occur in undisturbed soils. So if you're tilling the soil, then you're not going to have a higher vascular mycorrhizal fungi population. The other thing is that without it's hard to tell that you're not going to be able to really intuit that without, So to make sure that they're there, you would inoculate. But they are there naturally, and especially in undisturbed systems, and you probably don't, if you have an undisturbed system that's undisturbed for a long time, you probably don't need to inoculate. And keeping, our vascular mycorrhizal fungi will survive winter temperatures and they can go dormant, but if you keep them, if you keep crops in the soil that they can associate with, they'll continue to make connections with those crops. So.
Would a snake test be a good indication of vascular mycorrhizae?
A what test?
Snake.
What's that?
Maybe I'm mispronouncing it, but basically you grab a plant and try and gently take it out of the ground, and then you put it into a vessel with water, you suspend it above the vessel with a screen or something.
Yeah.
And so it's suspended in the water, and you gently agitate it, and you basically are looking for glomulin as an indicator. So
Well, if you're looking for glomalin, then I assume that I've never heard of that. I've never done that. But yeah, I mean, if you're looking for glomalin, then it sounds like that might be that could be a good indicator. I mean, I'd have to look more into that, but that is really interesting because that would be a good way for people to sort of and do some at-home analysis, which is, I think, like the best thing. Is it on YouTube? Would you say it was called a slate? Slate. Like snake with an L. Okay.
Yeah, slate as in the stuff that slakes off.
Oh, yeah.
The less, basically, my understanding is the less diverse or less microbially active soils more of it will end up in the bottom or in solution.
Yeah.
And so the healthier soils have more longevity.
Yeah.
Stick to the roots.
Yeah. Cool. Yeah.
Does it true that garlic help keeps certain bugs and insects away from the plant?
That what keeps that?
Garlic.
Oh, yeah. Well, that's debated, but yeah, I think it has some sort of effects like that. A lot of like radish and things like that. Also, anything with like glucosinolates will have that.
They say to use garlic with roses.
Yeah, they say people say use garlic oil, and I don't know why. I don't know if it's for like its antimicrobial properties. Like, I mean, also like in herbal medicine, you would use garlic for as an antimicrobial. So I don't know if that's the reason or if there's another reason. I haven't really ever used it in terms of. I think it could. I think for. Well, I don't know if it's the smell for like microbes and things like that, right? But it could be. I mean, I don't know. I mean, yeah. I guess there's been conflicting research. I think that it is something that's recommended a lot that people use garlic oil.
I have a zucchini plant I planted right next into my garlic.
Oh yeah.
Just for the heck of it, and that plant had no spot bugs on it at all the whole summer.
Yeah, so then there you go.
We're like inundated with them,
Yeah.
picking them all the time,
Yeah.
It does work.
Yeah. Actually, I didn't have a chance to talk to her about it yet, but Caro, the organizer of the winter conference, was telling me that she had a year where she planted garlic into a cash crop. I don't remember what it was, but it was something. It was some sort of green with multiple cuttings, and so what she did was she had one cutting, and then you're nodding like you know. Yeah. What do you know what green it was?
I want to say it was like
Yeah, but
DPO or I don't know what
yeah. So, but anyway, anything with multiple cuttings, she said it worked really well. She was just pressed for space, but I think that's another like really good option in terms of these alternative garlic production systems. I mean, it's not really like soil building, but also like an efficient land use efficiency. From a land use efficiency perspective, it's a great way to intercrop without competition.
So I didn't get the answer to that question. I didn't understand it about whether there's a natural way to find that AMF or not.
Oh, so basically, I don't. It sounds like there might be an at-home there might be an at-home way to test it, which is called the Slate Method, and so that's something.
No, and then you said to buy the stuff to put next to the plant.
Oh yeah, you can buy that at any like farmers co-op.
But is there a natural thing to buy, or is that natural?
It is natural.
Oh.
Yeah, so it's a fungi. So it is a naturally occurring.
So it have to be organic.
Yeah, so it is organic.
So any kind of farm store would have it.
They'd have it, and it'd probably be organic certified. So, yeah, I got mine. I live in Franklin County. I got mine at the Greenfield Farmers Co-op, and
Feed store,
yeah, the feed store.
Any thoughts on sort of a home gardener or any soil, your basic soil thing, especially if you're kind of creating a raised bed and you're using, like a mix kind of thing versus using the soil, sense of clay as your base and then adding to that. Is there sort of a sterility period, you think? Like, I just experienced that myself in a soil situation that's almost entirely
From an outside source.
yeah, like peat and compost and vermiculite kind of almost seed starter mixes that seem to be sterile.
Yeah.
And how to time it takes to build up that?
Microbial community? Well, I think it depends on, I don't have a numerical answer, but I think that a lot of it depends on your amendments in terms of like soil organic matter or like compost or something that will actually provide food for the microbes. So if you're feeding the microbes, and even if that is like living roots or something, then that'll attract more microbial activity. So similarly with the carbon to nitrogen ratio, if you're putting in a lot of things that have a low carbon to nitrogen ratio, then you're stimulating microbial activity. So you can actually build up your microbial population faster by adding basically sources of food. Yeah, and I think that's a great question. That's something I really don't know, and I would really be interested in too. Is how quickly do these populations establish, and how long do they stay in the soil, and especially, and how quickly do they do they expand in the soil, and what causes decrease, and what affects these populations. I mean, we know that like nitrogen fertilizer can affect a lot of these microbial populations negatively. Like rhizobia will respond negatively, which is what associates with legumes, will respond negatively to applied fertilizer. Mycorrhizae, or most fungi, will respond negatively to applied nitrogen fertilizer. So I think it's all about management practices at that point to determine like the rate of like building up your microbial population. I don't know if that was a clear and good answer, just a lot of words, but.
So, because you don't know yet how well it will like mulch the crop in terms of weed suppression, it's not really minimizing like bringing in like inputs
In terms of
like
mulching.
buying straw,
Yeah, exactly. So that's a great point.
It's more like the goal.
Yeah, so that's our goal in terms of minimizing, because that's, I think, one of the biggest costs is the mulch, also the labor. So it's like if you're going to have to pay for labor and straw in the spring, then that's little incentive to do this system and just push that in, especially because the spring is such a busy time. So at that point, you're still getting the soil health benefits, which I think is really worth it. But I think you have to be really oriented towards that goal. But that's also why I'm really interested in these mixed cover crop systems, because I don't think that just oats are going to give you a lot of. No, they are. I think they're going to give you soil health benefits, but I think it would be better to have some sort of mixture. But I think that they do have the best chance of mulching because they are straw. It's oat straw,
Are you going to experiment with like living mulches?
Yeah. So that's something that we're going to start experimenting with, but we're still doing like the very preliminary.
Living mulches?
Yeah, so we're looking.
Seeding another crop in after the first one winter kills, like in the spring, seed a new crop in.
Yeah.
That'll act as a living mulch, so it'll suppress weeds you don't want, but it'll grow.
So we're looking at
With the
we're looking at a perennial living mulch that's called Clover. It's smaller than like white clover, and because they actually use it in lawns, so it's something that we just thought this could be an interesting thing to plant into because it's so small and it doesn't really flower as much. But right now, like we have greenhouse studies, we're looking at seeding rates and things like that. We're actually planting corn into it right now to see how well the corn performs, just because sweet corn is so much more, it's fast growing. Also, you can't plant garlic in the greenhouse, but it's not going to, that doesn't matter. Either way, we're putting corn into it. We're putting corn into it right now. And we're looking at systems with with living mulch, with sweet corn, and with this garlic production. But that's sort of, I didn't even want to touch on that yet because we're still doing the preliminary results on this one. And with living mulch, it's such a, it's such like a whole new world because sometimes it really doesn't work. There's a lot of competition. There's a lot of issues with like management. So until we really get that down pat, I'm not gonna really recommend that anybody do that. But I think that's like our natural next step. I think is living mulch for the system, which I'm really excited about because again, like that's like the best part about like working on a research team is that there's mean, of course, I feel like this is being recorded, I shouldn't say this, there is economic loss, but I mean, like, it's not like it's your livelihood if this works or doesn't work. It really gives us the freedom to be like, this is a system that theoretically could work. It could help growers. This is what people are interested in. And if it doesn't work, that's not our livelihood, is growing this crop, you know. So.
Can you just say again, when does your cover crop die back? Just
In December.
Just after,
Actually,
so after the frost.
Yeah, some of them, yeah. Theoretically, first frost, but actually a lot of them will withstand the first frost, and you can have a few frosts, and they'll die back steadily.
And then it's just enough debris to keep it from freezing on.
Yeah. So yeah, exactly. Yeah, because that's the point of
That
mulching.
seems questionable, right?
Well, it's yeah. I mean, it's interesting. I mean, in the winter, I think it's fine because you have a lot of biomass. From all the treatments we did this year, we had enough biomass to form like a frost for the winter. So I think in terms of frost heaving, we're fine. There's a lot of biomass. I think the real issue is going to be weeds in the spring because I mean, some of these crops, they like, especially fava bean is incredibly cold tolerant, which is why we originally tried to use it in the system. I mean, that keeps growing like way after a lot of the other cover crops die back. And I think that field peas are also, I mean, the winter peas are also going to be pretty cold tolerant. But yeah, all of these treatments had significant biomass. But like I said, I think come spring, some of these plants are going to decompose really fast, and so that's going to be not that great for mulching. And like the other part of that is, and this is where like with decomposition, why I'm so obsessed with that is, okay, you have all of these plants that decompose really fast. Are they, since the soil needs to be at a certain temperature for microbes to start being active, and then obviously for like the garlic to sprout, are all the nutrients that are released, are they all released at the same time in this really rapid decomposition, and by the time the garlic sprouts, are those nutrients gone, or is there some synchrony? And that's where you get kind of, we start to play with carbon to nitrogen ratios and rate of decomposition, because the idea is that we want these nutrients to be steadily available during the active growth of garlic and not just decompose and disappear, or not, decompose after the garlic has undergone active growth and then they're not really contributing at all, So that's a large bulk of the research, is sort of pinpoint how fast these residues decompose, because this system aside, then you can use that knowledge to manipulate other systems and be like, all right, well, I know that, decomposing oats are going to provide these nutrients at this time versus,
I'm sorry.
Oh, sorry.
Is garlic considered to be a heavy eater? Because I feel like
it's a heavy night.
I don't have to do anything.
Yeah, well, it's considered, the recommended rate is 120 pounds of nitrogen per acre for garlic, which is considered a heavy feeder. So, yeah.
Does onions / garlic have the same effect on the soil, seeing that they're supposed to be the same family?
I don't know. Yeah, I have no idea. I think that generally people think of garlic as having more like allelopathic effects than onion, but I just don't know. Maybe it's just because I've read more about garlic than I have about onion and its allelopathic effect. But I don't have a straight answer to that.
Do you think now think about the biomass that is left from the cover crop residue actually providing heat as it decomposes to the crop, more so than straw or a winter row cover system? I wonder if, and I don't know how much decomposition happens if it is freezing, right?
No, so in freezing temperatures it won't happen. You need the soil to warm up. But
I wonder if it'll sprout earlier. I wonder if it'll raise the temperature of the soil in the spring as it does decompose and provide some extra heat.
thought about that too, and I don't know if it'll sprout earlier, but I do think I do think that that's a great point. And I just anecdotally, my mom uses raised beds, and she adds a ton of compost. She just plants tomatoes into compost really early, and frighteningly early, and you're just like, this is never going to work, and it does, because the decomposition really warms up the soil. That's really interesting to see. That's going to be really interesting to see. I don't know if it's going to make a huge difference or not. who knows? Especially because the garlic is further down. It's not really sitting at the surface. But we'll see.
When you say when you put down compost,
Yeah.
and you put down early, we have worms at the soil.
Well, it's hypothetically yes, because it basically gives microbes a food source that they can start to work with early on at a time where like they're just starting to metabolize, and otherwise everything at the ground is still frozen. They're very sort of immobile at the time.
Other thoughts? I know you don't want to tell people to do living mulch, but like, you know, it's not a big deal to try it on like a tiny piece.
Yeah.
That's like, you know, maybe 9, you know, whatever it's going to be.
Yeah.
20 heads of garlic, like on our scale or whatever. Like besides the mini clover, do you have other thoughts? Like if we wanted to just like try a tiny patch and like see?
You know, I would probably use another type of clover, like maybe another miniature clover. But
like a vetch, like something that's a little spreading, like a little bit.
Yeah, maybe like a vetch would work too. Actually, if you give me your contact information, so I think that my boss, my advisor, Masood, would like love to talk more about because he's been doing this for so many years, so he knows he has a lot of thoughts about like what to put in and why not, like much more than I would. So I think if you're actually interested in trying something like that, he would have a lot of thoughts, and I would really encourage you to talk to him. I think he'd be really excited too. He loves people experimenting. So
for the green, but for the living mulch, I think I could try this.
Yeah.
I mean, it wouldn't be incorporated into the full.
Yeah, no, but that's fine. I think that it's fun. I think it'd be really interesting to see what happens too in terms of just easy weed spread. You didn't mulch your garlic, or you did?
We did mulch it with straw, but I could just uncover like
a little part of it and see. Yeah.
I can see that. I uncover my mulch like the end of March.
Yeah.
All the way.
Oh yeah.
So the soil warms up more.
Yeah.
You know.
Huh.
Then
Interesting.
by early May, then I put my mulch back on it again.
Yeah.
And the half of the garden I did last year, the garlic came up tall faster. Because I warmed the soil up.
We didn't straw mulch it this year. We used winter weight remake.
Cool. Okay. Yeah. So then that's a lot easier to remove.
Yeah.
I think. I mean, it's kind of a pain in the ass to
You're
deal
gonna
with
remove
it.
it anyway.
Yeah.
But it's a lot more work with keeping up the weeds if you don't use the straw mulch, but it's a lot less labor to use a remake.
Yeah.
Initially. Like that
Initially.
white, fabric. Yeah. Row cover. Remake is like a brand.
Yeah.
It's like saying Kleenex. You know?
I just chop up leaves.
Yeah.
I have an abundance of them, right, in the fall.
Yeah.
So I just pile them up and I double chop them up and go on more into like little pieces.
Yeah.
That's awesome.
I'm cheap.
And I ended up putting lettuce in between my rows in the spring. Because I have so much lettuce that it seeds itself, so they come up really early, and then I just transplant them in between.
Yeah. Oh, that's really smart. That's a great
But
idea.
I end up having mulch, like little, between these little spaces.
Yeah. I mean that's really interesting to think about too. Is just using like other like cash crops as like a mulch in a way, kind of, Because then that also just I think the biggest thing that for me that with this system is it's just it seems like a lot of wasted space if you're not intercropping in some way. If you're operating on small acreage, especially, I think it just takes up a lot of space.
Is there a general thing that people follow a garlic crop with? Like sometimes I've done late cucumbers or something, but is there something that's sort of an established rule for that?
Not that do you know?
Follow garlic?
Yeah.
After you go out. No. I usually would cover crop that after, just because like the garlic's been feeding for so long on that.
What do you usually use for cover crops after?
Because
you plant
mix to what you were saying.
Yeah. Like you do mixes mostly.
Like oats and where I am now, yeah, we mostly, yeah,
And you plant,
almost always do a mix.
and you plant them like midsummer in July, or?
I mean, it depends on the season. Like, we've been fallowing a lot of our land right now because we've like really reduced our CSA. So we've been getting to really like treat our fields in a way we haven't before. So we've had some of them in cover crop the whole season.
Yeah. Oh, that's really
But
cool.
otherwise, it's whenever.
Which where are
At
you?
the farm school in Athens.
Oh, okay, cool.
Yeah. So we definitely work with the extension a lot.
Yeah. Oh, awesome.
Yeah. And we've had some people from extension come out for our adult, students.
Yeah.
Or we'll come out and do like pruning or whatever with some of your professors.
Yeah.
So, yeah.
Cool.
It's a cool relationship, but I think that's cool. Like we're a nonprofit, so definitely there's budget concerns for sure. We have to make a certain percent, but also we do have a little more of that.
Yeah.
Freedom to be more of
we don't have an
educational-
unlimited budget at all. Like, I mean, we're definitely like budget conscious, but I think that it's the same thing. It's like it's not like this is your livelihood in the sense that this has to work, which is I think why it's especially important that you get like community and grower feedback, because if you're working on something that no one's ever going to care about, then like you're just wasting you're wasting your resources of like not of being able to do research that is actually going to help people. So, but yeah, anyway, I want to get your contact information too. If you want. It'd be really cool to get some of this stuff together.
We almost tried into mulch this year, but it was like such a last minute idea. Like we almost tried planting a cover crop.
Yeah. Well,
but it was too late.
Yeah, you have to like plan for it, and you have to get the bed
mass. We did like a bed, and we were like, okay, we're gonna plant just this one bed into into the cover crop, but like it wasn't in row enough. Like we were thinking more if we planted it early, it died, and then we planted it into the biomass as the mulch.
Yeah.
Like we were thinking of an early crop, let it die back, and then in the fall plant right into that breaking down cover crop, and then that would provide the mulch over the winter. So
that's interesting. Yeah,
it's the same thing except your way's better because you have the cover crop alive.
Yeah, well, yeah.
We were gonna mow it and then plant it.
Yeah.
But I don't know why. I don't know why we wouldn't just let it winter kill.
When I think maybe logistical issues too. But I talked to David Fisher, Natural Roots, about this. Who said he tried to do this with the living mulch and it didn't really work because it was just too hard to get into the residues. But what he does now is kind of a similar thing where he grows oats and then he does a genius thing kind of, I think. But and he's not feeding the soil microbes in the fall, but he grows oats like this, and then he plants his garlic right here, and then he mows, this market is boring, and then he mows, he plants his garlic right here, and then he mows his oats and rolls them over to mulch his garlic.
Like,
so that
the crimper
the roller crimper.
Yeah. Roller crimper. Yeah, that was our thinking too. We don't want to have